Hi, it's Bradley from General 3D. Today I'm going to show you how to make a bottle opener. It's a deceptively challenging design, at least the way I did it. I know it looks simple, but there's a few things that at least tripped me up, so maybe you're smarter than me, maybe not. I guess you'll have to watch to find out. So let's get started. As with any design, we're going to start with a little sketch here. Alright, and we've got some dimensions there. And then, of course, when you start the sketch in Fusion 360, the first thing you want to do is add some parameters as well. You can pause and save those if you need. Alright, we'll start our first sketch. And then just rough drawing, get everything lined up after you get the basic shape. They're going to do all of these constrained lines first, and then you want to go on to your splines and things that are going to be variable throughout the design. Also, these constraints aren't perfect. I recorded this earlier in the video, and I ended up tuning it myself to get some of these just right, and you'll probably have to change them a little bit yourself anyway, just in case your printer's not printing exactly the same as mine. If your extrusion multiplier isn't perfect or whatever, it's better if you tune this stuff exactly to work on your printer to fit a bottle cap. The way I've got mine is it'll actually kind of clip on top of the cap before you pull it off, and it'll hang on pretty tight. And you pop the cap, and then it should hang on pretty tight there as well. Right, so here's our first spline. A big mistake I see a lot of people make here is to use too many fit points for the splines. So you really want to use as few as possible. I think there's one extra one in here we're going to have to delete. And there might be one I added in, I can't remember now. But just bear with me while we get this perfect. It'll take quite a while, but it'll definitely be worth it once you get it finished. That one's useless. Don't forget the ends can be adjusted there. Now while I do this, somebody asked about doing a pressure analysis or stress analysis of some sort, and the reason I haven't done that in Fusion 360 is because I don't think it'll do a great job with 3D printed parts. When you're 3D printing stuff, especially small simple stuff like this, I find it easier just to go ahead and print it out and then test it, and we'll add an extra fit point right there to make a better thing. But because the parts are hollow and because of the process of 3D printing, I find it better just to kind of trial and error for most things. And you'll get a feel as you get more experience, if you haven't already, of what'll work and what won't. The obvious main things to watch out for are sharp corners, like that top corner in this model, the 100.7 degree angle. That's one part probably the main part you're going to have to look out for, because it has to fit that bottle cap. We can't add too much of a chamfer to it. And I did add a 1mm after this recording. I think that's one thing I forgot to do while making the video. But if you add a 1mm there, it's not going to be perfect, and it's not going to have the convex shape that the rest of the bottle opener will have, so it won't be quite as strong as the rest of the bottle opener. So that's going to be your weak point to look out for. And another thing I changed was I added, in this video, I did a 8mm wall from that corner to the top of the bottle opener. I found 10mm to be as strong as I wanted. And part of that problem could have been that I tested the part while it was still warm from printing. It might not have completely cured, so to speak. But I was able to pretty easily bend it with my hands, so I ended up making that a 10mm diameter there that I just set. I also did it here as well, but that part's probably not necessary. It felt pretty strong when I tested it on that first part, but I did it anyway just to be safe. It's not a big deal either way, probably for that second one though. Now here I'm going to try to get that bottom overall length line. Try to get it lined up with those 3 spots. The first design I did, it didn't really line up, so it would kind of rock if you put it on a table. It'll do that. And I just found that annoying. It's not required, but I did that. And then here's a kind of sketch of where the key ring is going to be. Just make sure that it's going to fit roughly anyway. We can tune that size later if we have to. I'll start doing some lines here. These are going to be used for extruding the part upwards and sweeping the parts that need to be curved to fit around the bottle cap. This is the first part that I thought was a little bit tricky, was trying to get these placed strategically to make the rest of the process as easy as possible. Alright, don't forget to save. It looks like we're about ready to start extruding here. You really want to spend a little extra time. There again, I'm trying to adjust that even though it was pretty close, but you really want to get it perfect here. This, if you don't get it right here, once you get farther into the design process, it's going to be a lot harder to make changes. Just the way that this was drawn, especially with the lettering at the very end. If you have to go back and make any geometry changes or shape of the bottle opener, it's going to take a lot of time. You're basically going to have to redo it, considering how long it takes to update all of the different sketches that we're going to make throughout this entire process. So take your time at this point, get this exactly right, make sure that top curve is as straight and consistent as possible. Make sure everything's hopefully thick enough. I'm going to show you a spot here not too far into the design where you can stop and tune the dimensions of those teeth to grab the bottle cap. Even on my design, I still need to go back and fix that main tooth. It's a little bit long. In hindsight, that's going to be a problem too, with those 3 points being level. But I guess you live and learn. I'll deal with that on my own time. I'm not going to make you watch that in this incredibly long video. There's a circle for the shape of the bottle cap, and then we're going to sweep around. Don't forget to set it to parallel instead of perpendicular. The first few designs I used parallel, and it was a very long process of working around fixing that and making it work well despite that. These arrows always throw me off, but I'll figure it out eventually. There we go. Alright, it's starting to kind of look like a bottle opener. We've got some weird geometry there in the finger groove, and that's probably the main challenge with this design. It took me quite a while, and I've tried probably a dozen different ways of cleaning that up, but I finally found a really good solution, and that's mostly why I wanted to share this video. I think it'll give you some ideas for how to clean up weird geometry that happens like that on some of these more complex shaped models. And this will be kind of the difference between making your own model and any model that you can download on Thingiverse. I'm pretty sure there are a few that are pretty similar to this design on Thingiverse, but most of the ones I looked at, I wasn't really satisfied with the shapes and sizes of them. They can be pretty square. Like, you could probably sweep around this whole thing and square it up and make it pretty simple shape, but it's going to be a little bit weaker just because it doesn't have the curves to help reinforce the printed layers. and it's just not going to look as great or feel as good in the hand, and you won't be able to put your own name on your bottle opener or whatever you want on that back curve. Here I'm trying to figure out why it won't slice the body. I've never had that problem before. There must be some sort of weird geometry going on in there. I'm going to try a few times, but it's one of those things in Fusion 360. Sometimes it just doesn't go perfectly. I'm going to try to make some adjustments and figure out what's confusing it. It can be weird things every now and then. But at the end, after you get tired of trying it, then you really just got to figure out a different way to work around it. Remember, step back in your design until you can get it something that actually works. So here I'm just going to do an offset plane for half the width of the part, because as you can tell, we're working on just half of it, and we'll mirror it and get the other side later. It's a lot easier just to work from a half design when you can. There's definitely times where that won't work, but this is one of those times where it's much easier to work on just half of it. Alright, now here when you do this plane, you might want to go a little bit farther down and to the left. It'll make a steeper angle. It'll feel a little bit better. Where I've got it now, I actually changed it on my design as well. It's going to be a little bit square. You can see that angle that we're intersecting there. It's not really as steep as you might want it to be. Not in my opinion anyway. It'll work fine, but it's just one of those things it'll make it feel a little bit smoother if you bring it back towards the very front, the little tooth there on the end of the bottle opener. You don't want it all the way on the end because it'll make the edges too thin, but definitely I'd recommend bringing it back a little bit more than where it is now. And when you're doing the sweep, don't forget to change that orientation to perpendicular. We set it to parallel before, and that's what's throwing me off right here, I think, too. I'll figure it out eventually. Here we go. Alright, now we're getting into the spot that's going to be a challenge. You can see it's kind of making a weird sliver there at the very end. I thought it would sweep a little bit farther and get rid of that, and it's kind of one of those shapes that Fusion doesn't really like. It's a very thin spot with a very sharp angle. That can cause some problems sometimes. You can try adjusting that, but in this case it's not really going to make any effect. The ultimate solution is going to just be to back it off a little bit to make a sizable shape there that Fusion can handle better in the future, and we'll get rid of it with a couple operations afterwards. And we're almost there, but right now would actually be a good spot too if you could slice this bottle opener in half using that weird geometry. Now would be a good time to start printing your first version, so that you can test the shape and size of those teeth and make your adjustments while you work on the rest of this. We'll get there pretty soon in the video, but I'm going to clean up this geometry first while we wait. So just do an intersection there, do another box just like I did with the sweep all the way around. Alright, here's our second one. This positioning of these planes doesn't have to be perfect, but you'll see if you watch ahead a little bit before you actually do it yourself. You want them kind of at a flat area, but you want it to also be curving down, because of the guide rails for the loft that you're going to use. You want them to not cross over the outer perimeter of the edges of the bottle opener. So there's the two profiles are looking pretty good. I'll start a sketch here to do our first spline to be a guide rail for the loft. And don't forget again, you don't want to use any more fit points than you really have to. And make it a little easier. So in that interest, we're just going to do each end and then drag them around, and you'll have plenty of control using just these two control points here. You can lock it to the edge there to make it easier to control too, but if you want to get it right on that line, you don't want it too far in either direction. You want it to be as smooth of a transition as possible, but make sure it doesn't cross over. It's going to make a little lump in your part. It would be very hard to clean up without making the geometry look kind of weird. Sorry about how jagged this looks. I know it's a very low frame rate. I didn't realize at the time when I was recording that it was only going to be in 10 frames per second. But I'm using the screen capture app that you can install within Fusion 360. Next time I'll try to use OBS or something like that with a slightly higher frame rate. It is unfortunately choppy. It almost looks sped up, but this is actually the speed that I was working. Before this recording, I'd actually drawn this entire thing probably twice trying to get a good recording. But I got hung up in a couple spots just from weird Fusion mishaps that it was acting weird. Sort of like when I was trying to splice it back there and it wouldn't slice the body to make the entire top of the bottle opener flat. I had a few problems like that with the previous two attempts, and it made the time go up to 45 minutes to an hour for each of those recordings, so I knew I could get it shorter, and this one looks like it'll be about half an hour, maybe a little more, but not too much. Alright, now that we've got that cleaned up, add a little fillet there. You could add a little fillet on those two new edges that it made on either side of that loft. I probably should have, but it's not a big deal. We did pretty good keeping that smooth. And now we're going to chop the bottle opener in half. You don't really need that entire handle to print your test pieces. So you just chop it off. It'll make the print a little faster. You can test or trial and error and get a working model much quicker. If you don't have those ticks to fix every time you make a change to the shape, and if you don't have to wait on it to print an entire handle that you don't need to see if it'll fit on the cap or not. And of course, before you print it, don't forget to mirror and combine the two pieces. You want to print the entire thing. It's not going to be much use in printing half of it, or a quarter of it, really. I misnamed it, but in this case I'm just making it for the video, so I'm not going to test it right now. I'll go back and do that after this recording. Alright, and while you're printing your first versions, if you haven't already, or while you're waiting on a version 3 or 4 to print, you can go ahead and add in this Keyring Hole. This is another one of those little features that you're not going to get on a Thingiverse model. And you're actually going to be able to, if you know how to make this keyring hole actually fit the keyring and have a path where it fits the keyring perfectly instead of just being a hole straight through the part. It's one of those little features that you probably couldn't even get in a actual injection molded part, at least not as easily as you could a 3D printed part where you can make any geometry you want. So model that slot on the top, and then we're going to projected onto a perpendicular plane. And we're going to draw the circle that'll represent the actual keyring, which will be basically the path for the slot to be swept through, or extruded through, basically. There we go, and then decide the diameter, which should be a parameter, hopefully, if you're doing it right. Alright, and then just sweep the slot through around that keyring. Perfect. Alright, so here's where you really want to stop. You don't want to go any further than this without being sure that the shape of your bottle opener is going to work for you. If you go any further and you have to change it, you're going to have to redo everything basically after this point anyway to make the lettering work. So there's really no reason. You'll just be wasting your time if you go beyond this until you're ready with your final version. I did that several times and I regretted it every time, so don't make my mistakes. So in order to get that text where it says bottle popper on the top of the bottle opener that I showed you at the beginning, you could extrude it straight on, but if the curve of the top of the bottle opener is too steep, you're going to get some distortion in the letters, and I'm sure you've noticed that with other models. If you have a lot of experience in Fusion 360 and you try to put letters on stuff like I do anyway. So in an attempt to get around that, we're going to use the sheet metal flanges. And I'll walk you through it here. I'm not sure if this is really the way it was designed to be done. It kind of seems a little bit iffy about if it wants to work sometimes, and it can cause a lot of lag after these letters are extruded onto the part as well. And you'll notice that as we get into it as well. But it works. It's not super easy, and as you can see, I'm struggling again with unfolding these curves. I figured out after this recording, if you would have clicked on the back side of that face, it probably would have worked. But in this case, that didn't occur to me for some reason. I really just wanted to unfold it on the face that I was going to be extruding onto, I guess. So I worked around it by adding the tail on the other end eventually. Sometimes changing angles too, or making that an exact tangent like I did just there. That can help sometimes, but really just try the back end of that on the other side, or add that tail on the other side like I'm about to do here in just a second. I'll do that, and then I'll still try that one just to see if the tail helped, and it didn't. So we'll unfold it with the other one. There we go. Again, I'm pretty sure that's not the way. I saw this as a trick online, and it works pretty well. It's a little bit buggy like you saw, or it doesn't work the way you might think that it should, but it works most of the time anyway. So now that you've got a flat surface, you just put your text on there. You might have to eyeball it a little bit because those tails will add a little extra material where you can't really print the part, but make it go as far into the flange as you can without going all the way through. If you go all the way through, Fusion 360 is not going to be very happy. So this is another part where sometimes it'll throw some weird errors, and it might be easier just to delete the whole thing and restart the flanges if it throws a fit. It usually works without too much trouble though. And there we go. It worked well this time. Alright, so we've got the text going around left to right, and well, it accidentally cut through the part a little bit there. We'll go back and fix it in just a second. That's unfortunate, but there's also a curve going up and down as well that we're going to account for. If you're only insetting the text maybe 0.0 or 0.2 millimeters, which is what I usually do, if that curve is too steep, it's going to be very obvious that the top of the letters is way less inset than the middle of them. So I'm going to show you a trick here to make another flange, and then you combine them, and then you'll be able to thicken and extrude them into the part with the proper curves. And then there'll be a consistent inset all the way around the curve, both side to side and up and down. That's just a much more professional looking result than if you just extruded straight onto the part and your letters are all distorted. It's one of the limitations of Fusion 360 that I'm not a big fan of. I'm not sure why this process has to be so hard. But once you figure out this process, it's not that bad. It takes a minute to learn and figure out exactly how it works, but as long as the program doesn't throw any weird errors that you can't figure out, then it works pretty well. Just make sure you save it for the last step, because like I said, if you have to go back and fix it, you're going to have a bad time. Here's another one of those things where Fusion does kind of a weird thing with the geometry. I don't know why it's leaving those zero thickness walls there, but it's an easy fix. I'm gonna make sure it's on the right setting. So we'll fix the sketch. We'll just make it a little bit thicker so that it'll be obvious that we want to take that entire thing. Alright, that's a nice curve. Combine them, you can see if you take both of those together, it's going to make a nice curved letters inside. As long as you got that curve far enough in. You could clip parts of the tops and bottoms of the letters off if you didn't get it deep enough into that second flange. But as long as you extrude the letters as far as you could into the first one, and you got that arc pretty deep into the second one, you should have plenty of margin for error. Alright, now we need to change to the patch environment, and I'm going to select for an offset for each of these. There's no way to extrude that plane because it's curved letters, and they're curved in both dimensions, unfortunately. So it's kind of hard to get it to be able to extrude that into the part. But if you take this offset, and then we're going to take that offset and thicken it into the part as a cut operation, you'll get exactly what you want. You can see the letters, and when we thicken it, we need to know exactly how far to go. It takes too long to do the operation if you don't know exactly how, because every time you change the distance, it takes quite a while to calculate. So 2.553, you would think there's a way to copy that to save it for later, but there's not. So just memorize that, whatever that number was for you, and thicken. Select all the parts. I'm not sure why shift clicking isn't working. I'm going to try control clicking, and we'll just have to stick with that. So click each letter. And then we're at 2.53. So we'll add the 0.2 millimeter inset that we want, and we'll get a 2.73. It could have been a little bit more. We're going to come a little short, but it'll be close enough, well within the margin for error. Change that to a cut because for some reason it doesn't automatically do that, just like a sweep or extrude would. And then here's the lag that I explained earlier. Maybe you won't have as much of a problem with it. I'm working on a 4670 i5 processor, but I really need an update, but I make do with what I've got. I guess I'm too cheap to upgrade right now. Give it a few more seconds. You can already see it looks like it's going to do what we would want it to do. And you can go ahead and remove that stuff if you want to keep it clean over there. We've got a weird line in here, but we've got a 1.73, 1.77 right there in the middle, 1.77 all the way at the top. It's same all the way around, top and bottom, middle of the letters, all the way around the curve of the bottle opener, all the exact same inset. So that's exactly what we wanted. I think it would be pretty obvious if you were lazy and the letters weren't uniformly inset into the part. It comes out in the print if your printer's printing as well as it should be for a print like this. But that's how you do it. The only thing that's left really is we'll add the letter or the words bottle opener to the other side. That'll just let people know if somebody finds it on the street or something. Don't forget to save again. But that way, if somebody finds it and they don't know what it is, it might not be obvious to somebody who didn't actually make it. They'll be able to tell what they're looking at. So on this side, I'll show you kind of what happens if you're lazy about it. And it'll work a little bit because the angle of that grip goes back and forth across the central angle, which is selected there. But it's not ideal, but I'm too lazy to go through that entire process just for a short word on a relatively flat plane. Next thing, they move the perspectives. I need to line it up and make sure I'm getting it perfectly lined up on that plane. Something weird is going on with the constraints, and it's messed up. I'll just delete it and restart. At a weird projection point there. Really, the only part of this word that's going to be a problem is that B. You can see it's kind of going on the left side of that arc. It angles away. It's going to stretch it out a little bit, but because of the shape of the letter, it's not going to be super obvious. Give it just a second to process that object. There we go. Make sure you have that second chain faces. That'll make your life a little easier. And then a 0.2 offset. And it auto selects cut. Perfect. Give it a few seconds. Compute. There we go. Perfect. You can tell it beats a little bit, but it's not too bad. I don't think anybody would notice unless they're looking for it in your model. And then over here we'll just do opener. It's a nice flat surface, so there should be no problem. The only challenge is getting the size right. That should just take you a few seconds. A little small, a little big, and we'll get it just right. There we go. Alright, but that's basically it. That's the bottle opener. Hopefully it wasn't too confusing. If you had any questions, please let me know. I'm always willing to help out. I've definitely gotten plenty of help from the 3D printing community myself, so I'm always more than willing to give back in any way I can. That's why I made this video in the first place. But yeah, check out my website if you want to see some other models. I'll consider making more videos. If you like this, let me know, and I'll make another one. I've got a virtual reality motion controller pistol grip. I'm thinking about making another one of those, so if you'd like to see that in a video, let me know. There's also a puzzle ball you'll find on my eBay page if you're interested in seeing how I made that. That was a fun toy from my childhood. I really enjoyed drawing that as well, so I could make a video of that as well if you're interested. You can't figure it out. So let me know what you think, and we'll talk to you later. Bye.